Good evening, all of you. So today we'll discuss about combinations of errors. Okay. So in combination of error means if two individual quantities are there, like suppose you are measuring the area of a rectangle or any same any object, then there is a length and breadth. Suppose you are measuring the breadth and you are getting some error in breadth, and you measured the length and you are getting some error plus minus 0.1 centimeter, something like that. You got some error in length also. Then you are finding out area. So definitely when you will find out the area of this rectangle, you are finding length, you are finding breadth. Then when you find area, that is length into breadth, so as there is some error plus minus, let's say delta L, and breadth also you are getting plus minus delta B. So that means you are getting some error in breadth, some error in length. Okay, that means when you will find area, you will also definitely you will also find some error in area, because you are multiplying these two things and each individual has some errors. So how will you find out? So you will also get some A plus minus delta A also you will get in the result. Okay, so these are called combinations of errors. We can means we know from a single error, we can calculate your absolute error, relative error, and the percentage error. But if two quantities are added, subtracted, or more, their product or post divisions are there, or if the formula like a to the power p, b to the power q, c to the power, such type of formulas are there, then what will be the error in the result? For example, if you are finding out the time period of a pendulum, the time period of a pendulum is 2 pi L upon G under root. Now you are finding some error in length, some error in G, then what will be the error in time period? Okay. So that's why there are different formula. For example, you are finding centripetal force. The centripetal force will be mv square upon r. Okay, so if you are measuring mass of the object, there is some error in mass, then there is some error in velocity of you are measuring the object is moved, revolving in a set circular path. So the object has some errors in the velocity, and also while you are measuring the radius of the circular track, then also you are making some mistake, plus minus some errors are there in your R also. So when the errors are there in mass, errors are there in velocity, and errors are there in your radius, then what will be the error in centripetal force? Obviously, it will have some error. So it will come under this general formula. So now we will prove this formula and we'll check and we'll try to get the result for that. If the formula is A plus B, then what will be the errors in the result? If the formula is A into B or A minus B, then what will be the error in the result? Or if it is in the like general formula, if the formula is like this, then what will be the errors? So it will be a slightly longer video, but we will try to complete all the derivations clearly. So the first one is if the result is sum of two quantities. For example, suppose first one we will discuss, that is error in sum of two quantities. Error in sum of two quantities. Okay. So what will be the error in sum of two quantities? Z is equal to A plus B. Okay. Z is equal to A plus B. Now, what will, if A has some error, B has some error, then what will be the error in the result Z? So we can write that Z plus minus delta Z will be the error in Z when we write A plus minus delta A. because A has some error we measure, plus B has also some error. So B plus minus delta B. Now what will be the value of this delta Z? What will be the error in the result? That is delta Z we are interested to calculate. So then we can write A plus B like this. A plus B, and error part we can separate out. We'll write the error part in a step. Then this will be plus minus delta A plus minus delta B. Now A plus B is your Z. What is remain is delta A plus minus delta B. Okay, so Z plus, you can write this is Z plus minus delta Z. This is also Z plus minus delta Z. Now you can see Z plus minus delta Z, we are getting Z plus minus delta A plus minus delta B. Right. Now you can write from this equations, you can from this equation you can if you compare the left side and right side, you can easily see that this delta Z will be this rest of the part, del A plus plus minus delta A plus minus delta B. Now we are interested to what can be the maximum error in delta Z. So what will be maximum? If I will write delta A minus delta B, it cannot be maximum. So if we are interested to find that what can be the maximum delta Z, we will write. So maximum value of delta Z will be delta A plus delta B. Okay, so when two quantities are added or when we are finding out the sum of two quantities, then there will be the error in the result will be the sum of individual errors. Clear? Now if difference, let's go to the second case. Error in difference. Error in difference of two quantities. Now similarly, quickly I am doing, that is A minus B. If the formula is A minus B, then what will be the error in Z? So I can write Z plus minus delta Z, which is equal to your A plus minus delta A minus B plus minus delta B. So I can write this is A minus B. I brought the B near A, so A minus B plus minus delta A. Minus, if I take it inside, then it will be minus plus. Minus into plus, minus, minus into minus plus. So minus plus delta B. Now A minus B is your Z. So I can write this is Z plus minus delta A minus plus delta B. Clear? Now this is your Z plus minus delta Z. This is your Z plus minus delta Z. So what is delta Z? Now for subtraction also, or difference of two quantities also, will get the same thing. How? You can see. So this delta Z maximum, if you want to get, you have to again add delta F and delta B. Then you will get the maximum delta Z. Okay. So maximum value of delta Z will be delta Z will be again delta A plus delta B. So here we can conclude that we are getting for both sum and differences, but sum and differences we are getting same delta Z. Okay, the error in the result will be sum of individual errors. Clear? Now we'll go for the product. Okay, let's go for the products of two quantities. errors in the product of two quantities. Okay? So products means your result will be A into B. Okay, result Z is equal to multiplication of two individual quantities. Okay. So what will be the error in the result? So error in the result will be Z plus minus delta Z. Same procedure will follow. So A is will be errors. There will be some errors in the measurement of A. Let's say this is delta A, and multiplication B plus minus delta B. Clear? Now let us multiply. So A into B, A into delta B plus minus A delta B. Now B into delta A plus minus B delta A. Now delta A into delta B, that is plus minus delta A delta B. Now see, delta A is a very small number, right? Small number means like 0.01, 0.1, like that. And delta B is also very small number. Generally, these are errors. So error must generally are small. So how you will multiply to fractional small number? The result will be again a small number, right? For example, if you 0.1 into 0.1, if you multiply, then this is 0.01. So 0.01 is less than 0.1, isn't it? Okay. So when you multiply to small fractional number, the result will be more smaller. Okay. So delta A into delta B is very small. So approximation will take, will make it approximately, will put it 0. Then what will remain? AB is your Z plus minus. Okay, AB is Z plus minus, and A delta B, B delta A. We'll keep it A delta B plus minus B delta A. Okay. Now, so what is this? This is Z plus minus delta Z. Implies that this is Z plus minus delta Z. Okay. Now I will divide Z both sides. So here I will get the fractional error. Instead of we are getting directly del Z, we will get the fractional or relative error of Z. Fractional errors will get. So here I'll divide Z both sides. Divide Z both sides. Okay. So what I'll get? This is Z by Z1 plus minus delta Z by Z is equal to Z by Z, that is, or we can do one thing. This Z cancel. Okay, so divide Z both sides. What will take, right? Now delta Z by Z. Here in the right side, instead of dividing Z is equal to AB. Now, so what we'll do? I'll divide, instead of dividing Z in the right side, I'll divide AB. It's my choice because AB is there, so it will be cancelled out. That's why I'll divide instead, because AB is equal to Z. So I'll divide AB. So A plus minus A delta B by AB. No, left side I have divided Z, right side I am dividing AB because Z is equal to AB, because it will be easier for me to cancel some quantities. B delta A, this is also AB, B cancelled, A cancelled. So you can see what remain, plus minus delta Z by Z is equal to plus minus delta B by B plus minus delta A by A. Okay, so the maximum fractional error will be if I take the fractional error plus this. So I can write maximum fractional errors. So percentage error, I'll multiply 100, right? Maximum fractional error. So maximum fractional error will be, I'll take the plus delta a by a plus delta b by b, because this will be the maximum value of this combination. So maximum fractional error will be delta z by z is equal to delta a by a, okay, plus delta b by b. Okay. So if two quantities are multiplied, okay, and the result, what will be the error in the result? So maximum error in the result will be the fractional error of individual errors, okay, or these are relative errors. We will just multiply 100 and we'll again get the percentage error. Actually so many question comes based on this one, okay, in the entrance also.